Alright, so we will finish the practice test right now with the last problem from 13.5, and this is number 50 to 56. So here, this is another greatest common factor problem. It's already in standard form, it already equals 0, and the common factor is equal to tangent. So we'll set this equal to tangent being factored out. And then if you pull out a tangent from this first one, you get negative rad 2. If you pull out a tangent from this one, you get minus secant. So let's make each of these equal to 0. In the last video we solved this when we said that tangent is equal to 0 at 0 and 180. So we'll just reuse that solution. And then we need this one to equal 0 as well. So let's add radical 2 to both sides. And we would get negative secant equals radical 2. We'll divide by negative 1. Now here's the problem. We don't really know as much about secant as we do about the other equations. So here's what we can do to fix that. Secant equals negative radical 2. We know what cosine is, though. Cosine is the flip of secant. So if we flip this over, we would get 1 over negative radical 2. And let's rationalize that denominator. This would be negative radical 2 over 2, not radical 2, over regular 2. And by the way, all I did with this negative, it was on the bottom, and you can put it wherever you want, so I put it on the top. So which angle does cosine have equal to radical 2 over 2? It's 45, but it's negative here, so that means it's going to be in the two quadrants where cosine is negative. So 45 in those two quadrants that I just circled, which would be right here. Okay, so this angle is 180 minus 45, which is 135. This angle right here is 180 plus 45, which is 225. So four solutions: 135, 225, 0, and 180. We'll check that's a 0, 135, 180, and 225. That works. Okay, both of these problems right here are going to involve using the trinomial strategy 4. And you can kind of tell if you look at the first one, you have something squared, you have something to the first power, and then you just have a number. So let's move this other one over. So this is going to equal 0. We'll have 2 cos squared. I'm going to put this one right next to it so it looks like it's in standard form. And then 4 minus 3 is 1. So this can factor. We've done this a couple times so far. 2 cosine squared, the only way to get that is 2 cosine times cosine. The only way to get the positive 1 is 1 times 1. So now we need to set each of these equal to 0. So cosine equals negative 1. We'll deal with that in just a sec. And then 2 cosine plus 1 equals 0. We'll subtract the 1. And then we'll divide by 2. So cosine equals negative 1/2. Okay. So let's start with so these are our two values here. Let's start with the negative 1. So here's a unit circle. Cosine is the x-coordinate. Where does the x-coordinate equal negative 1? Right here at 180. So there's our first solution. Now looking at the 1/2, which angle has a cosine of 1/2? It's 60 degrees, but it's 60 in the quadrants where cosine is negative. And cosine is negative in quadrants 2 and 3. So we need a 60 right here, and we need a 60 right here. This 60 is 180 minus 60, which is 120. And this other 60 is 180 plus 60, which is 240. We don't have to check our solutions because as long as we did the rest of it right, because we didn't square anything right there. We just factored. So 180, 120, and 240 should be our answers. And there it is. Alright, this one right here is another trinomial. So let's add the 1 to both sides, and we'll get 0 equals, I'm just going to write this with the squared term in front, and then the tan to the first power second, and then this one. Okay, this will again factor. What did you do to get tan squared? You multiplied tan times tan. What did you do to get the 1? You did 1 times 1. Okay, and this is nice because this is actually just one solution really. It's tan plus 1, the whole thing squared. Okay, so we need that to equal 0. So we'll set tan plus 1 equal to 0. We'll subtract the 1 from both sides. Oops, and let's move that up a little bit. So tangent equals negative 1. When does tan equal 1? Tan equals 1 at 45. So our reference angle is going to be 45, but tangent has to be negative. So it has to be the quadrants where 45 gives us a negative tangent. And the two quadrants where tangent is negative are quadrants 2 and quadrant 4. So this 45, whatever that angle is, and this 45 right here. So let's verify what those are. So this angle here is 180 minus 45, which is 135. That's one solution. And then our next solution is this angle all the way around except for that last 45. That's 360 minus 45, which is 315. So 135, 315 should be our answers. We don't have to check them because there's no way we got an extremely solution. We didn't square both sides. Alright, 53 and 54. So this is a strategy that we haven't really seen so far. And it's strategy 5, using a Pythagorean identity. And just to recall the Pythagorean identities, they're on the top left of this page. I would point to, but it doesn't highlight, just going to highlight the page where the arrow is right here. So these are the 3 Pythagorean identities. And the reason we want to do this is we want to change it so that there's only one trig function showing up. And in terms of which trig function, so in 53, which one do you want to show up? You want a cosine to show up because 2 of them are already cosines. So why not make a sine squared into a cosine? And we can do that by using this identity. Sine squared plus cosine squared equals 1. Let's solve this for cosines, or sorry, for sine squared. So sine squared is equal to this thing right here. So let's substitute that in. So we still have this negative cosine. This thing is equal to 1 minus cosine squared. So I'm going to sub that in. And we still have that minus cosine squared right here. Let's simplify these like terms. So we have negative cos squared minus cos squared is negative 2 cos squared. And we have this minus cos right here. And then we have the plus 1. And I'm going to multiply everything by negative 1 because I like that first term to be, it's easier when that first term is positive. So 0 times negative 1 is still 0. And then everything in here times negative 1, that's just going to reverse all the signs. Not sign like S-I-N-E, but sign like positive and negative. This chapter is filled with bad puns. Okay, so this is now going to factor. This is something that a strategy that we've used before. So how do we get the 2 cosine squared? It was 2 cosine times cosine. And then how do we get the 1? It's only 1 times 1. And the signs have to go like this, positive and negative. That's the only way it would FOIL out to this thing. So now let's set each of these equal to 0. And we'll start with the right one, that's a little bit easier. So we'll minus, that's a 0. We'll minus 1, so cosine equals negative 1. Where does that happen? Here's our unit circle. Cosine is the x-coordinate, and the x-coordinate is negative 1 right here at 180. So I'm going to circle that, that's one solution. And then the other part right here, when we add 1 to both sides, we get 2 cosine is equal to 1. We'll divide by 2. So cosine is 1/2. Where does that happen? Positive 1/2. Cosine is 1/2 at, not at 30 degrees, at 60 degrees. And it's in the 2 places where cosine is positive, which is in the first quadrant and in the fourth quadrant. So one solution is going to be 60. The other will be 60 in this last quadrant, which is 360 minus 60, and that's 300. So 3 solutions, 60, 180, and 300. Let's check to see if we got it, and we did. Alright, last one. So remember, the strategy we're using right now is Pythagorean identities, which is strategy 5. So we need, on this problem, we need to find a Pythagorean identity that involves tan squared and secant. And there is one, it's this one right here. Tan squared plus 1 equals sec squared. How do I decide what to do? Well, I have a secant here already, so I want to change the tan squared into something with secant squared. So let's solve this for tan squared. So that goes away. Tan squared equals that, so let's make that substitution. So 3 secant plus 3 equals negative, and then we're going to plug this in right here. Sec squared minus 1, let's distribute the negative, so we get 3 secant plus 3 equals negative sec squared plus 1, because negative times negative 1 would be positive. Okay, then let's add the sec squared and subtract the 1. Add the sec squared and subtract the 1, so let me move this over so we'll continue the problem right here because we had a bunch of work over there. So this whole side equals 0 now, and this side right here simplifies to sec squared plus 3 times secant, and then 3 minus 1 is 2. So this will factor now. This is going to factor to secant times secant is secant squared, and then to get the 2, we must have done 2 times 1. So now we can solve this. We want to set this equal to 0 and set this equal to 0. We'll subtract 1 right here, and we'll subtract 2 right here. So secant equals -1 and secant equals -2. Now again, we don't really know as much about secant as we know about the thing that goes with secant, and that's cosine. How do you get from secant to cosine? You just flip it over. So if we flip -1 over, we'll still get -1. And if we flip -2 over, we get -1 over 2. So we want to find out where these things happen. Where does cosine equal -1? Cosine is the x-coordinate, and the x-coordinate is -1 right there. So theta equals 180, because that's where that yellow dot is. It's at 180. What angle has a cosine of 1/2? Cosine is 1/2 for 60 degrees, but it's 60 degrees in the quadrants where cosine is negative, because that's a -1/2. So cosine is negative in this quadrant, and it's negative in that quadrant. So this angle is 120 degrees. There's one solution. And this angle right here, 180 plus 60, would be 240 degrees. So we have solutions of 120, 240, and 180. So 120, 180, and 240, and that works. Alright, last two problems. This is the final strategy that we haven't seen yet. So this is strategy 6, squaring both sides of the equation. How do you know when to use that or when to do that? Here's what you do. So there's no obvious way to solve this right now. Let's add the 2 cosine to both sides, just so we can combine the like terms. So we get sine is equal to -cos plus 2 cos would be cosine minus 1. So now we're at this point, we can't do anything. So if you remember the other problem, like on number 53 or 54, what do we do here? We saw that we had a sine squared and a cosine squared, and we used this identity. Or we saw that we had a tan squared and a secant, and so we used the identity that had tan squared and secant. On this one, we don't have anything being squared, and yet the Pythagorean identities involve things being squared. So what do you do if you want things to be squared and they're not being squared? Like, we want this identity to be usable, and we can't use it right now because we have, these are not, sine and cosine are not being squared. So what do you do if you want something to be squared and it's not squared? And the answer is you just square it. So we're going to square both sides so that we can make a Pythagorean identity. So this left side is sine squared. When you FOIL out this other side, you get cos squared minus 2 cosine plus 1. Okay, why do we do that? Because now we can use this Pythagorean identity. Now if we solve for sine squared up here, okay, sine squared is equal to this. It's equal to 1 minus cos squared. So let's replace that. Why did I replace that? Because now this is going to be something that we can factor. We can make a trinomial out of it. And we couldn't have done that if there was there are 2 different types of trig functions there. Okay, so let's simplify this by subtracting 1 from both sides and by adding cosine squared. So that goes away, that's 0. Cos squared plus cos squared is 2 cos squared. The 1's go away, and then we have minus 2 cosine. So this is actually not a trinomial, this is a greatest common factor that we can pull out. If you look at what's there, they both have a 2 in common, so we can pull that out, and they both have a cosine. So if we pull out a 2 cosine from this one, we're just left with cosine. If we pull out a 2 cosine from itself, we're left with 1. So now let's set each of these equal to 0 like we've done before. And we'll add 1 to both sides right here. We get cosine equals 1. We'll divide by 2 here. We get cosine equals 0. Okay, now here's the thing. We need to check our solutions in this case because we squared both sides. And remember, we did that on the other type of problem, and that resulted in extraneous solutions. So let's do this. Cosine is where the x is the x-coordinate. So where is the x-coordinate equals 0 and 1? It equals 0 right here at 90, and also right here at 270. And it equals 1 right here at 0. So we have possible solutions of 0, 90, and 270, but we do need to check those. So 0, 90, and 270. So let me just erase this right here. So we're going to check 0, 90, and 270 because probably some of these will be extraneous. So 0 right here, we'll check that, then we will check 90, and then we'll check 270. Start with 0. So we're going to plug in 0 here and here, and you know what, actually let's check it from the sine equals cos minus 1 part, because we know that's a little bit easier. We added 2 cosine, we know that this is right. So sine of 0, does that equal cosine of 0 minus 1? Sine of 0 is 0, cosine of 0 is 1. So 1 minus 1, that does equal 0. So 0 is a real solution. That one checks out. Let's test 90. Sine of 90, does that equal cosine of 90? minus 1. Sine of 90 is 1. Cosine of 90 is 0. 1 does not equal 0 minus 1, so 90 is an extraneous solution. And let's try 270 now. Sine of 270, does that equal cos 270 minus 1? Sine of 270 equals negative 1. Cos of 270 is 0. 0 minus 1 does equal negative 1, so that's also a real solution. So 0 and 270 are the only ones that work. The other one was extraneous. Alright, last problem. This is like a marathon chapter. There's a lot of problems here. All good things come to those who wait. So we're finally at the last problem. So here we go. We want a Pythagorean identity, and since it's tangent and secant, we want this one to appear. And that can't happen right now because nothing's being squared. So what we need to do is square both sides. So let's start by adding the tangent. And the reason I'm adding the tangent, by the way, is it's easier to have just a single thing on one side to square. So try to make that happen by isolating at least one of these. So negative 2 tan plus tan would be negative tan. And then we have that equal to secant. How do we make the identity appear? We square both sides. And remember, when we square both sides, that means that an extraneous solution might result. So we're going to need to be aware of that. So when we FOIL this out, negative tan minus 1 squared is tan squared plus 2 tangent plus 1. And the other side will be sec squared. Okay, sec squared equals this thing. So let's substitute that in. Why did I decide to substitute that? Because all the stuff on the left side is in terms of tangent. So that makes the most sense. Let's substitute tan squared plus 1 right here. And that's equal to tan squared plus 2 tan plus 1. And actually this one is not going to be so hard because you'll see what happens in just a sec. We'll subtract the 1, those go away. We'll subtract the tan squared, and those go away. So only thing we're left with is 2 tangent is equal to 0. We'll divide by 2. So tangent is equal to 0. Remember that tangent is sine over cosine. So we're really being asked to see where does sine equal 0. Because if cosine equals 0, you're dividing by 0, and you can't do that. So where does sine? Sine is the y-coordinate. Where does the y-coordinate equal 0? Equals 0 right here at 0, and equals 0 right here at 180. So those are the two solutions, but we do need to check because we squared both sides. So let's check from this point right here before we square both sides, because that is a little bit simpler than checking the original. So we'll check 0 degrees, and we'll check 180 degrees using this equation. Negative tan minus 1 equals secant. So negative tan of 0 minus 1, does that equal secant of 0? And then over here we'll do negative tan 180 minus 1, does that equal secant of 180? So secant is the same as the reverse of cosine. So the cosine, let's do this. Tan of 0 is 0, so this is 0 minus 1. Secant of 0, well, cosine of 0 is 1, so if you flip that over, you would also get 1. So 0 minus 1 is negative 1, that doesn't equal 1, so this is extraneous. Okay, tan of 180, well, we already said that's 0, so 0 minus 1. Sec of 180, well, let's find what cosine of 180 is. Cosine is the x-coordinate at 180, it's negative 1. So if you flip that over, if you flip the reciprocal of negative 1, you would still have negative 1. So 0 minus 1, that does equal negative 1, so 180 is the only solution that works. The other one is extraneous. So that is chapter 13. Hopefully that helps clarify some things. And this chapter is all about practice. So the more of these problems you do, the easier they become.